the title in the agenda is actually a little bit different. So this, than what's listed. I actually have a presentation this afternoon that follows that title, although the content for this session does overlap a decent amount. So this is accelerating the deployment of open SDN-enabled broadband access systems. So the best comparison is, if you set in maybe the DTA4 presentation yesterday, that would be a good example of what we'd consider an SDN-enabled broadband access system. So kind of that cord-based architecture, so more on the fiber aggregation side, fiber access and aggregation side, whereas the last presentation covered what was happening in evolution of the CPE market, moving to white box, moving to kind of how virtualization is applying. This is kind of the same kind of shifts in the industry, but happening in the aggregation, fiber aggregation systems upstream from the CPE devices. Now, if I summarize kind of some of the big trends that's going on right now in the fiber access space, there's a lot of impact that 5G is going to have, and that's really from a fiber densification. You're going to have a lot more fiber connected devices that need to be aggregated to the network. That's helping push edge cloud infrastructure. There's IoT use cases also pushing edge cloud infrastructure. The combination of that and then operators wanting to converge their residential business and X-Haul solutions or connectivity all onto a single network, that is driving us to kind of revisit, how do I build these scalable fiber access networks of the future? So in DT, they kind of outlined that use case yesterday, their vision for A4, what they call their Access 4.0 architecture, and it adopted a lot of this same, general principles. Now, how you go about doing it, this fourth bullet here really talks about the newer approach to building these web scale architectures, and that's these open disaggregated blueprints that kind of follow an industry reference design. And so that's where the ONF comes in. So ONF being the Open Networking Foundation, they're now providing a set of reference designs that for operators looking to deploy these type of networks, DT being one of those, AT&T, other operators are very vocal in this community. It provides a common reference design for them to kind of build this converged fiber access network of the future. And so that's what I'll talk about today. So SDN-enabled broadband access, or SEBA, is a industry term that specifically comes from an ONF reference design. So the SDN-enabled broadband access reference design, which we also a lot of times called SD access before, now maybe we'll start calling it SEBA, but when we talk about SD access, we're talking about this fiber access infrastructure, and it's usually built on what we'd call data center architectural principles of it's open, it's disaggregated, you virtualize where it makes sense, but you certainly implement open networking architectures, and that includes aligning with open reference architectures where they exist. And so that's where we'll spend most of our time discussing today. But before I get to behind the details of the architecture, ultimately what everybody's trying to get to is this customer self-service model. A lot of what we just talked about in the last presentation about, hey, a user-driven service portal, I mix and match VNFs on the CPE side of things out at the edge. Well, you also may want to mix and match VNFs in the edge cloud environment and pair that with different broadband connectivity speeds in the fiber access system. So if kind of the end goal would be, if you kind of compared the last presentation, I've got VNFs out at the edge, I have at the customer edge, I have VNFs also hosted in the edge cloud, being at the central office or aggregation sites in the network. And then I have fiber access systems that are more of these open disaggregated systems. I need all of that infrastructure to be programmable under kind of a single user-driven service catalog approach. And so when we talk about SD-enabled broadband access systems, it's really this system, but it's this and maybe the combination of this VNF. How do I build a reference architecture for all of this piece of the network? And so that's where SEBA and some of the others come in. Where we are in the timeline for SD access, so we started early trials in these open disaggregated systems as far back as about 2012. A lot of the early days of first talking about cord and stuff came along a little bit later, a couple years later. There's been a lot of, POCs, lab announcements, things like that, but now we're really this year and start going into next year where you're really starting to see real world deployments. And so much like NFV and other industry, other areas like SD-WAN and stuff where it was talked about a while now, it's really moving forward into the field. Well, SD Access is kind of moving out of the lab and into the field really this year and into next year. And mainly the motivation for that is that a lot of these use cases that we're trying to build these scalable fiber. Absolutely. That was not planned. There we go. All right, so as you look forward to like 2019, a lot of these use cases around 5G xHaul, Edge Cloud, they're starting to mature all at the same time. And so now we're starting to see a lot of ramping up of deployments. So ONF has been a big part of that. ADTRAN joined ONF as a partner earlier this year, basically because the timing's right. A lot of these deployments are going into real large-scale field deployments in 2018, 2019. So, it's, hey, we see this happening. It's an industry trend that's not going away, and let's participate in that. And I'll go through, kind of where ADTRAN fits in that. But that's really, what we've seen a big difference. Now, the ONF issued a new strategic plan earlier this year. They announced it in March of this year. And it was, hey, how do we get these solutions into large-scale field deployments? How do we get out of the lab and into field deployments? We don't want to keep referring to this as POCs and other things. We want it to be real deployable software. And so what we've seen happen in the industry, so when they set out the strategic plan, they said, okay, well, we've been working on a lot of these open source components, and that's where Volta, ONOS, XOS, Stratum, all of these pieces come into play. There's new components like NIM and stuff. So these are software components, platforms that have been built out over the past few years. Let's take that and then assemble those components into a reference design. And that's what, SDN-enabled broadband access that I'm talking about today is one of those reference designs. I'll show you on a chart in a minute how some of these other reference designs intersect. But UPAN is kind of like a next-gen SDN protocol suite. NFV Fabric is a leaf spine switching fabric, and ODTN is a transport use case. So they'll build these blueprints or reference designs, and then the operators that support them will then they'll maybe add a little bit and create their own derivative of these reference designs, and those will be called exemplar platforms, exemplar being an example of the reference design. And so they'll take those then into market. Now, there is a role in here I'll talk about later with solutions integration partners, and that's kind of where ADTRAN fits, to help get these products really into a production stage. But this is the general model that the ONF has defined. And so an example of this, and so the point being, hey, I want to build out this edge cloud and new fiber access infrastructure. Well, how do I go about doing that? Is there a blueprint that I can follow? And so any aggregation network will kind of start with, from a networking infrastructure, you have the leaf spine switching, data center switch architectures. Well, there is a reference design for that and includes software and everything. So it's called NFV Fabric. So that actually runs ONOS as an SDN controller. All the control plane traffic runs in the controller. So it sets up a whole leaf spine switch architecture, and it handles it basically. This combination leaf and spine switches looks like a single router entity, and there's actually routing protocols through vRouter that are exchanged with upstream peering routers. But this actually includes the software that runs on the switches as well as a reference white box hardware, so that you can get up and running with a leaf spine switching architecture at pretty much zero software licensing cost out of the gate. You may need a solutions integration partner to help you deploy it and maintain it, but at least from a software licensing perspective, you can start out with 100% open source software and then white box hardware and be off and running. Now, on the access side of that, and that's the connectivity out to the customer, there are disaggregated OLT blades that support technologies like GPON and XGS-PON that you connect into these aggregation switches to then provide the fiber connectivity out to whether it's a 5G radio or a small or a enterprise user or residential user, it's providing the connectivity out to the edge. Now, there's a couple of other software platforms that come into the picture as soon as I adopt access technology like CBUTs. One's Volta as an access abstraction layer. There's a set of apps that run in the same controller as the fabric switches. And then there's this network edge mediator that provides a set of operational tools and abstraction for this fiber access system. So now I'm building up this pod So if you can imagine, this would be in a central office exchange type location or a hub site if you're an MSO cable operator, and you would have your leaf spine switch architecture in the kind of a data center type form factor. You'd have these OLT fiber access blades, and now I have software here under a common control layer, all programmable, 100%. At least all these platforms are all open source platforms. So you're getting everything, at least starting out, including access and aggregation from the open source community. Now, if you want to add transport to then interconnect that aggregation site with other sites, there is a reference design for that. So for transponders, to program transponders underneath a common SDN controller, handle telemetry information, there's another reference design for that. And then later, the next one coming out will be, hey, if I want to put edge compute infrastructure, either at an upstream aggregation site or here co-located with the OLT, like you see here, hosting VNFs. If you have UCP hanging off of that, that's not integrated right now, but that would be in the future. You can now have reference design software for that entire, for everything from leaf spine switching, transport, access, edge compute infrastructure, and in the future, even mobility. Now, this M-Cord and multi-access edge compute is a little bit earlier days, but now you can kind of see if you're building this new fiber aggregation network and you're trying to figure out, okay, which direction do I go? Is there an industry standard that I follow? I wouldn't say there's a specific industry standard. There's entities like the Broadband Forum that define industry standard APIs and stuff, which would get reused in this architecture. But this kind of gives you a nice blueprint to start from and says, look, you know, if DT joins and does this, and AT&T and Comcast and NTT and all these other operators go out and they adopt these kind of blueprints and they add and contribute back to it, that baseline reference software continues to get better and better and better, and the incremental work needed to make it production grade in your network gets less. So this is the way we see more operators following. There is a protocol suite with Stratum that adds a new programming suite. Google's doing most of the contribution in this area. And then obviously there's ONAP and other existing systems you may need to connect into. So this whole this entire stack, especially with ONAP, there's other open source projects. So what we see more and more operators doing is take this blueprint, work with solutions partners to then integrate that and get it operational in your network. From an ADTRAN perspective, our history is in the fiber access and aggregation space, but more and more it's helping operators make this transition and adopt these types of networks. So as I mentioned earlier, part of that being an ONF partner, ADTRAN has resources that are actively staffed alongside the ONF developers. So ONF themselves, just a little bit of background. So ONF has actual open source developers, vendor neutral developers in Silicon Valley. They have a full-time team there. So a lot of the funding that ADTRAN and other partners provide funds that group. In addition to that, we have our resources that are engaged in these projects, and they help you get these reference designs like SDN-enabled broadband access into a GA state. You heard DT say yesterday, if you attended that session, hey, we've been studying this for a few years now. We really like all the open disaggregated architectures. We like to follow the ONF reference designs, but we realized really quickly that we need integration partners to help that get into a production state. And that's where vendors like ADTRAN come in, is more of a solution integration partner for whichever operator. I'm not announcing a specific operator here, but just when we, going forward, any operator adopting these types of reference architectures, we can help them with that whole process. Now, ultimately, the benefits that you're going to achieve by following these reference designs, some of it's fairly intuitive, but just to kind of restate it, from an OpEx and CapEx perspective, obviously that's where the first benefit would come in. It tends to be more white box hardware, but it's probably more than anything, it's really modular. So if you go back to that like drawing, all of these piece parts are very modular, interchangeable parts. And all the intelligence really is in, a lot of the intelligence, I say, not all, but a lot of the intelligence is centralized here in the open source controllers and the abstraction layers. So the actual software running on these devices is less, and that makes them more interchangeable. There's less vendor lock-in when you have the underlying infrastructure is more interchangeable. There is a plug-in framework so that these devices can plug into an abstraction layer directly into the controller, and that's all open source. So it does make, now that the underlying infrastructure tends to be more modular and more white box, there's obviously some CapEx savings. There's also some OpEx savings because everything's automated. By having all this software centralized, everything from end to end is fully automated. So you get some benefits there as well. And the fact that you're building on a lot of open source means you don't have to have as big in a licensing perspective. You're building off of open source. So yes, you may need a solutions partner that offers targeted software components to complement the solution, but it's not like the entirety of the solution is closed software. So your software licensing support agreements, where they exist, would tend to be much lower than a vertically integrated closed solution. You do get the benefit of crowdsourcing and continual development. I mentioned like what Google's doing with Stratum. So that's already moving on beyond OpenFlow and into P4 runtime, gRPC, some of the, they'd call next-gen SDN. So you're getting some of the leading edge development from entities like Google, and this is really the Google data center guys that are investing in technologies like P4 runtime. That's getting contributed back into the community. So there's this continual innovation that you're not relying on a single vendor to spur along. And then, you know, it is easier to adapt to new solutions because you centralize a lot of the logic in these controllers, as I kind of go back to this drawing. Since a lot of the apps that really drive the underlying equipment is all centralized, it's easier now to introduce new technology, and you're not relying on, hey, there's a lot of technology tied up in this specific piece of hardware. When you centralize it, you tend to make the underlying parts a little more interchangeable, and you can kind of adapt to new solutions quicker. That modularity and the programmability also improves time to market for new services. That's probably one of the most important aspects of this. Ultimately, people want to get services. They want to bring new solutions, innovative solutions to market faster. So if I have an edge compute infrastructure, I can load VNFs quickly and automate it in an automated fashion under this blueprint, then that gives me a path to bring new services to market faster. And ultimately, this last one, there is a convergence aspect. Now that I have this blueprint that covers everything from, you know, residential access to business connectivity to future 5G xHaul applications, it does help drive, here's how I can converge organizationally. And you'll hear a lot of operators speak to this, like this was an opportunity. If I follow these blueprints, I can now converge my underlying network infrastructure. And so that's also kind of a side benefit that you get out of, you know, kind of adopting these reference designs and moving forward with them. So that was it. Any questions that I can answer? I've got like a minute or two here anyway. Okay. All right. Thank you guys. Appreciate it.